Hey guys, welcome back, and in this tutorial we are actually going to implement some texture caching. We're going to create ourselves a simple resource manager class. In the future this class will be used to cache all sorts of resources like models, meshes, all sorts of things, but for now it's just going to be textures. First let's go ahead and go into sprite.h and let's actually start, let's put some texture information in the sprite rather than just having it globally in main game. So first let's go ahead and remove player texture from main game completely. Go to maingame.cpp and remove this. I'm actually going to comment that out because I want to hold on to that file path so I don't have to type it all out again. And anything else in here? We don't need image loader anymore in main game because we're going to be doing it elsewhere. And this will change to the spline texture. We'll just leave it like that for now. So in Sprite, what we need to do is store a texture. Now we could store a pointer to a global texture, or we could just store a static texture. Or just an instance of a texture. Since it's so small, storing an instance of the texture would be pretty efficient. And since we're never going to unload textures right now, we're not learning about ref counting or anything like that. We're just going to, once we load in a texture, it's always going to be loaded into memory until the program exits. So a safe thing to do for now is just to say GLTexture texture here. So we'll just store our texture in the class like that. In the future, we may not want to do that, but we can always change that later. So let's include GLTexture, with quotations, GLTexture.h. All right, so now we have the texture in our sprite, but we need to actually be able to load the texture in. So let's add an additional argument to init. We're going to need string, so let's say include string. And let's say std string texture path, like that. And we'll put this same thing, of course, in the actual definition. We need to put it in both places. There we go, std string texture path. There we go, beautiful, beautiful. Now what we need to do is actually load that texture in here. And to do that, we're going to use our texture cache. And where is our texture cache going to reside? Well, it could be like a global static class or something like that, but we might want multiple texture caches in the future. What we can do instead is have a global or a static resource manager class that our game will use, and then any of our game functions and things can use this resource manager to get resources. It will basically dictate, how everything is cached and all of that. So let's go ahead and create a new class. Add class. Will start out very simple, and we may add a lot more functionality to this later as we build up our engine, and eventually we are going to actually turn this into an engine. So let's go ahead and say resource cache. No, not resource cache, resource manager, like that. I believe that's a good name, resource manager. And here is our resource manager class, really good. Right now it's pretty much empty, it's just got a constructor and a destructor, that's fine. Let's actually make this a static class, so let's get rid of the constructor and the destructor, like that. Okay, I don't want to teach you guys about singletons or any of those other programming patterns right now, so for now we're just going to be using a lot of static classes. Let's now go into our graphics tutorials and create another class. We'll create a TextureCache class, and this is a class that our resource manager is going to have that handles the caching of textures. We might also have a model cache in the future, any other cache, maybe a sound cache, things like that. Let's go ahead and finish, and all right, here is our texture cache. This will not be a static class because we might want to have multiple instances of it, but the resource manager will have a single instance of our texture cache. All right, so it's going to need a private variable. It's going to need a way to store the textures, and we learned about a map in the previous episode, so we're going to include map, and we're going to declare ourselves a map down here. So to do that, we say std_map, and just like a vector, it's a template, meaning you can basically specify what types it has. But unlike a vector, it takes two template arguments separated by a comma. The first argument is the key, and remember our key is going to be a string. It's going to be the file path, so we're going to say std string. The second argument is going to be the value, and in our case it's going to be a GLTexture, like that. And we're going to name this something. Let's just name it TextureMap. All right, and to get GLTexture, we have to include GLTexture.h. There it is. All right, so we have our map. Now let's write another function that returns a GLTexture, and it's going to be called GetTexture. Very simple. And we'll give it a std string file path. and this will be implemented in the CPP file. So what this is going to do is it's going to return a GL texture. If it can't find the texture, it's going to just give us a fatal error for now. In the future, we probably won't want to use fatal errors for that, but for now, since we're just testing this out and just learning about it, we'll just have it go ahead and crash the game if it doesn't work. So what it's going to do is look up in the map and see if the texture is already there. If it is, it's just going to return the existing texture. And remember, a GL texture internally stores this GLUint ID, which you can kind of think of as the pointer to the actual texture in memory. It's the ID of that texture. So we can safely make a copy of this small class and not, or this small struct and not run into any performance concerns. That's why I'm not returning a pointer, I'm just returning a copy of it. And if it doesn't exist, it's going to create a new one by loading it in with our image loader class and then pushing it back onto the texture map, and it will return that one. So let's go ahead and go into TextureCache.cpp and implement this GetTexture function. All right, we'll put it right here and make sure to specify that it belongs to TextureCache. All right, so it takes a string argument. This is the file path. So the first thing we want to do is look up in our TextureCache and see if it's already there. So what we're going to be using is TextureMap.find. This function takes, and we should give it the argument name here, texture path. Did I give the argument name in the header file? No, you don't actually have to put it in the header file, but it's a good thing to do. Texture path. Might as well keep it uniform, right? All right, so we pass in texture path to TextureMap.find, and what it's going to do is it's going to basically scan our texture map. So it's going to do the thing here where it traverses the nodes looking for an existing one. If it reaches a null pointer, it's going to return an iterator that points to map::end, which is what you would normally use when you were iterating. And if it does find it, it's going to return an iterator pointing to our element that we're looking for. So let's go ahead and get an iterator. And the iterator declaration for this is really long and annoying. So std_map, what did I do? std_map, and then the first argument is std_string, this is the key, and then we have GLTexture, that's the val, and then : iterator, and why does it do that? And then we're going to call it, let's just call it mit for map iterator equals TextureMap.find. Wow, what a long and annoying declaration. So what I'm going to teach you to avoid this is a keyword called auto. Now TextureMap.find returns an iterator that is this exact type, so the compiler can be kind of smart. What we can do is replace this really long and annoying declaration with auto. And what it's going to do is it's going to look at the return value of this and replace auto with that return value. So this auto will become this exact same huge thing that we typed out here. You can use auto in other situations. You can say auto my string equals we, and it's going to make this into either a string or a char star. I'm not actually sure. That's why it's not a very good keyword to use. If we change this to like a 5, it would be an integer. You should never ever use auto like this. You should never use auto for something as simple as an int. I mean, an int takes less time to type than auto. I don't know why you would use auto. That's not a good idea. The only time you want to use auto is for like long, complicated like template functions and things like that, like this mit iterator that's really, really long. And then you, just so you know, you can't say auto, temp and then semicolon. That won't work. You have to initialize the variable on the same line that you use auto. Otherwise, it doesn't know how you're using it. So how would it know? As you can see, if you mouse over, it says it cannot deduce the type. It has no clue what type this is supposed to be because you didn't set it equal to anything. So yeah, that's the auto iterator. Now you know, use it sparingly. It's just a way to make your life a little easier so you don't have to type so much. Now let's go ahead and check and see if we found it. So this will look up the texture and see if it's in the map and check if it's not in the map. So if mit is equal to TextureMapEnd, this is how you know that it's not in the map. This end is like a little special flag, a special iterator that basically says this is the end of the map. This is what you use when you're doing like a for loop to loop through it. It's the same end that you use for lists if you watch the list tutorial. If it's equal to end, we didn't find it. So what we need to do is load it in and insert it into the map. So let's go ahead and include image loader. There we go. So let's go ahead and create a new texture. So GLTexture, new texture, equals image loader colon load PNG. We created this, remember, texture path is the parameter. So this will load in a PNG file and return the GeoTexture, the new GeoTexture. If this fails, it's going to be doing a fatal error anyways, so we don't need to error check the return value or anything like that. Oops, there we go. All right, so now we have the new texture. Now we can insert it into the map. So to do that, we use TextureMap.insert. And insert actually takes what's called a pair, an STD pair. So let's go ahead and create a pair, STD pair. And just like a map, it's a template argument. It takes template arguments that tell you what type of pair it is. Now a pair is just two values basically that are kind of combined together. And in this case, it's going to be our key and value. So the key is std string and the value is GLTexture, and we'll say new pair, and we can initialize this with the constructor texture, and we can say the texture path is the key and the value is the new texture, and then we can pass in this pair into the insert just like that, and that will insert our new GLTexture into the map, and it's called new pair, not pair. There we go. That will insert our new texture into the map. And there's actually an even easier way to do this right here. There's a way to make it a little bit simpler. You can use the function makePair. This will create a pair for you out of the two elements, and it'll take care of the type and everything. So now we can just copy paste this inside part right here, texture path, comma, new texture, and it will create the pair for us. So we can completely get rid of this line of code. Just makes it a little easier for you. So insert it into the map, and this part right here is load the texture. All right, so we now insert it into the map, and finally what we need to do in here is go ahead and return that new texture we created. So return new texture. Very, very simple code, only a few lines of code here for the caching. Now this happens if it's not in the map, so if we need to load it. If we don't need to load it, then we're going to come out here, right? We could write an else, but we don't really need to because the if is going to return. So it essentially does the same thing. So now all we got to do is use this mit iterator. So mit is actually now, since it's not pointing to TextureMap.end, we are guaranteed that it is pointing to the element that we were looking for. It's pointing to the texture that we want. So what we can do is return mit, and since mit is a pointer, to access its elements we use the arrow. And it has two elements. It has first and second. That is because mit is pointing to a pair, just like the pair we inserted. And when you say pair.first, it gives you the key, which is the string, and pair.second gives you the texture, which is the val. So we want to return the texture. So we're going to say mit.second, or mit arrow second, since it's a pointer. And that is that. This is all we have to do to get a texture from our texture cache. So our texture cache is now implemented. It's very simple right now. Let's go ahead and go to our resource manager and give us a texture cache. So private, and we're going to make our resource manager a static class. So let's say static texture cache, like that. And let's go ahead and include texture cache there. And in the CPP file, remember with static variables, you always have to declare them a really weird way. You've got to declare them again inside the CPP file. Somebody's knocking. That's weird. Okay, so texture cache, texture cache. There we go. That will basically declare it and say that it exists. So let's go ahead and write in our resource manager. We'll basically just write a little wrapper function here that's going to get a texture. So we'll say GLTexture, GetTexture, std string, texture path. And this is going to do the same thing that our texture cache did. It's actually going to call the texture cache. This is called a wrapper function. It just wraps a function that does some functionality. So include, what am I trying to do? Include string. There we go. So let's go ahead and put, and this should be static. Let's go ahead and put this in our CPP file and implement it. So resource manager : get texture. Oh, my Visual Studio is freezing for a second. Get texture. And all right, no errors. So all we got to do is return TextureCache.getTexture. Notice why it's a wrapper. It literally does nothing but call the TextureCache getTexture. It's very simple. We could add some other functionality in here, maybe some error checking, some useful statistics stuff in here. Wrappers can be very, very, very useful. All right, so that is that. Now we need to use our resource manager in our Sprite class. So let's go ahead and include resource manager. There we go. That will allow us to access textures. And all we got to do is say texture equals, because remember this is our private variable texture. Texture equals ResourceManager : GetTexture, and we will pass in the texture path. And that's that. If this doesn't get loaded, it'll give us a fatal error, so we will see that it doesn't work. And I mean, that's all there is. So let's go ahead and in the draw function, we need to change something. We need to actually bind the texture in here. So we're going to say GL bind texture, GL texture 2D, and the texture that we are going to bind is going to be our texture, obviously. So we're going to say texture.id. And now normally we unbind everything, but we actually don't need to unbind the texture. Usually unbinding things is just a way to, ensure that we don't have any state enabled that we don't need enabled. But for textures, you actually don't want to unbind them because there could be another texture or another sprite that's going to use the same texture. And if you keep rebinding and unbinding it, that's really inefficient. Instead, what we should do is before we even bind the texture, we should check and see if the texture is already bound. And to do that, we can go in our resource manager, make a new static, we'll say GLUint, and we're going to call it currently bound texture. We'll just say bound texture. And this is going to be just a public variable. And anytime we bind a texture, what it's going to do is we're going to set this bound texture to that texture. And we should probably actually do this in some kind of texture manager, in some kind of wrapper class for bind texture. So for now, let's not do this. Let's not do this here. We'll do that later. For now, we'll be inefficient with our small code, and we'll just keep rebinding the same texture. That's fine. All right, so we don't need to unbind it. What are we doing? We are binding the texture here, and that will allow us to draw it. So let's go back into main game, and let's go ahead and get rid of that call to GL bind texture here. We don't need to do that there. And let's see, is that almost it? Almost. We have to now pass in the file path for the texture into the sprite.init function. So let's give this a test. Let's go ahead and first run it with just our sprite.init, and let's use print functions to print when we're loading it and when we're not, so we can see if the caching is working. So let's go to GetTexture and TextureCache.getTexture. Let's go here, and anytime we get a cache texture, we're going to say std_cout. Oh, I have to include IOStream. Include IOStream. We're almost done with this episode, guys. We're going to say std_cout loaded cached texture. And new line. And otherwise, we're going to say loaded texture. Like that. So we should, if we use the same texture, we should only get loaded texture once. And then we should get, we'll say, used cache texture multiple times. All right, and what I also want to do is in main game, I believe, where we do the input, we are printing out a bunch of crap. Yeah, we're printing out the mouse motion stuff. Let's go ahead and I'm just going to comment that out. That might come in handy later. Okay, and now let's go ahead and create two sprites. So right now the dimensions are 2 and 2, so it's going to cover the whole screen. Let's create two sprites that cover just two different quadrants of the screen. So we're going to have one sprite that does that, and we need another sprite. So instead of a sprite, just a single sprite, let's do a vector of sprites. So vector, sprite, sprites. Sprites. All right, std vector sprites. Did we include vector? We did not. Let's include vector. This will allow us to have multiple sprites. Vector. All right, so now we'll go back into main.cpp and let's just say sprites.push back, and we're going to push back a new sprite like that. And let's go ahead and initialize that sprite. And to get the sprite we just pushed back, we can say sprites.back. So we can say sprites.back .init, and we can pass in this right here. All right, so that will initialize our first sprite. Now, if we want to push back a second sprite, we'll just do this again. Push back another sprite, and they're going to use the exact same texture, except the x coordinate for this sprite is going to start at 0 instead of -1 in our normalized device coordinates. So we should have two sprites at the bottom left corner and the bottom right corner. Now when we go to draw, instead of using sprite.draw, we're just going to for int I equals 0, I is less than sprites.size, I ++. We're going to draw each of those sprites, so we're going to go sprites I.draw like that and get rid of this. And that should be all we have to do. Hopefully it's going to work just fine and I won't have to fix any bugs. So let's go ahead and run it, see if we get any compilation errors. Not seeing any errors, getting a few warnings. Sign unsigned mismatch, I get that all the time. And it looks like we are only showing one sprite here. So I will pause the video and fix this and show you what I did wrong. Hey guys, sorry about that. So the bug was actually pretty obscure. So I made 3 sprites here, and the issue is all of these sprites are being stored in a vector, this vector of sprites right here, and they are not stored as pointers, right? They are stored in the vector's array memory. So whenever the vector needs to resize its internal memory, like whenever you call pushback, remember I showed you before, sometimes the vector will increase its size by doubling its internal array. Once it does that, it deletes all the old memory and copies over the memory to the new memory. However, whenever it does that, if we go to sprite.h in sprite.cpp, in our destructor here, we made sure to delete the buffers with gl delete buffers. So anytime our sprite was destroyed, we called delete buffers. And what was happening was whenever the sprite's memory was getting deleted and recopied over to a new vector buffer, we were deleting the vertex buffer objects. So every time we called pushback, when we had just a few elements, it was deleting those things. So what we can do is either A, we get rid of this right here and we just remember to delete the buffers whenever we are through with a sprite, or B, what we can do is in main game, instead of having a vector of sprites, we have a vector of sprite pointers, and we allocate the sprites on the heap so that whenever we add new sprites to this vector, we don't need to actually copy all the sprite memory over and delete the original sprite objects. Instead, we can just copy the pointers over, which will result in the original sprite objects still being in the same spot on the heap and not having to call their destructors or anything like that. So I'm going to actually do it this way. I'm going to use sprite pointers. So it'll be a little less cache coherent, but it will allow us to resize our sprite array without worrying about that. So instead of sprite here, we're going to say new sprite, since we are allocating new sprites as pointers and storing them on the heap. And then instead of dot init, since these are pointers, this is going to be arrow init, like that. And then one last thing, when we go down to the draw function, instead of dot draw, it's arrow draw, like that. So now when we run it, we should get all 3 sprites, hopefully, and we just got one again. Hang on. Oh, duh, that was my fault. I did a -2 here because I was debugging some stuff. So now we should get all 3, and there we do. We get all 3. These are using the same texture, and as you can see, it's actually running a lot slower than it was before. We don't have a frames per second counter or anything like that. We're not checking the FPS. We're not limiting the FPS. So the speed of the drawing is completely dependent on how much stuff we draw. So if we push back, let's see if it runs slower if we push back a bunch more of these. So let's just do for int I equals 0. I is less than 1,000. So let's add 1,000 sprites and see if this slows down a lot more. And I++, obviously. All right. And let's run that and see how slow it goes. And now it's slowed to almost a complete crawl. It almost doesn't even look like it's moving because we are drawing 1,000 textures. We're rebinding the textures every frame. We're not batching. We're doing it in the most inefficient way possible. We're going to learn way more efficient ways to draw these things so that we will be able to draw 1,000 sprites and have pretty much no FPS drop at all. But before we do that, I think we might do our first challenge episode because there's a lot more stuff we still need to learn to make it super efficient. We might do some FPS counter stuff and things like that. I really want to do a challenge episode soon, but there's just a lot of stuff you need to learn before you can make your first game. So I'll try to think of a simple game that runs really well, even with our inefficient code right now, and then we'll optimize it all a bit later. Thanks for joining me for this episode, guys. I will put this code online for you guys to use. See you next time. One last correction, I got these 2 print statements backwards. This one is supposed to be use cache texture and the other one is supposed to be loaded texture. And if we do run it, you will see that it is indeed caching them correctly. Okay, bye guys.